Okay. Today we will go for the repetition of the first module, which helps you for the internals. So there we are going to study about the first heading. We are going to study about what do you mean by Q, what do you mean by temperature. So Q is nothing but a rate of heat transfer, T is nothing but a temperature. Then we are also finding about difference between heat transfer and thermodynamics. So what is heat transfer and thermodynamics tells? Heat transfer tells about the process how it is taking place. But the thermodynamics tells only after the equilibrium state. For example, heating process, let us take heating of milk. We'll take heating of milk. So with the heat transfer, we can find out how much time is going to take to heat the milk to certain temperature, or after at some time duration, what is the temperature of the milk, that also we can find out with the help of heat transfer. But in thermodynamics, we cannot tell what is the time required, or at some particular time what is the temperature of the milk. There is no equations. Only we can find out the Q value after attaining the steady state. After attaining the steady state, we can tell the Q value. But here we can tell the Q value with respect to time, with respect to final. Both we can tell. That is a advantage of heat transfer compared to thermodynamics. In thermodynamics, we have to wait till the steady state occurs. Here we are not going to wait till the steady state occurring. Here we are going to do the problem or find out the time required to attain the steady state. Here we cannot tell the time required. Here we can tell at some particular time what is the temperature. Means as the time increases, how the temperature varies, that we can tell. And what is the Q for that particular time, and what is the Q finally, that also you can tell. So there is there is an added advantage for heat transfer compared to thermodynamics. This is one important thing, that is difference between thermodynamics and heat transfer. The third one is definition of modes of heat transfer. There are three modes of heat transfer: conduction, second is convection, third one is radiation. You know the definition. Conduction means due to the lattice vibration, if the heat transfer takes place, that we are going to call it as a conduction. Convection, due to the bulk motion of the fluids, is called convection. Radiation, without having any medium, energy transfer or Q transfer takes place with the help of waves. So that is called as radiation. Then fourth, governing laws. This is very, very important. Governing laws for heat transfer. There are three governing laws. For conduction, it is called Fourier law of conduction. For convection, it is called as Newton law of cooling. And for radiation, Stephen Boltzmann's law. There are three laws, where those three laws means we are going to write up the equation. So what is the equation for Fourier law of conduction? Q is equal to Ka dt by dx. This is the equation for conduction. And Q is equal to Ha T surface minus T infinity. This is the equation for convection. And Q is equal to sigma epsilon area sigma epsilon T1 to the power of 4 minus T2 to the power of 4 into area. This is the Stephen Boltzmann governing equation for radiation. So those we are going to solve the problems based on those three. Basically, combination of those two, any two or combination of all the three will solve the problem. After that, we are having one equation called. After all this, we are going for three-dimensional equation. Three-dimensional equation for Cartesian, polar, cylindrical. So we are having three-dimensional equation for Cartesian, polar, and cylindrical. So in this Cartesian, we know we'll have a three-dimensional equation, bigger equation for all the three we'll be having. We'll be getting a bigger equation for all the three. I have done only Cartesian in the class. I given polar and cylindrical for a homework. I think probably you have submitted. Okay, polar and cylindrical is homework, and Cartesian I have done. In that Cartesian, we will have one term called alpha. What is this alpha? Called thermal diffusivity. What is the formula for alpha thermal diffusivity? Do you remember? Thermal diffusivity. Just a minute, I'll check out. K by rho C. This is the value for thermal diffusivity. We will get in the Cartesian equation only. If you do the three-dimensional equation, we will get the equation. In that equation, we will get one term called K by rho Cp. We are going to convert this K by rho Cp and rewrite that in form of alpha. That is called thermal diffusivity, which indicates the penetration ability of the heat transfer. That is the Q. That is the alpha. This is the one. And then after this, what we went? We went for 2D equation. 2D equation only for slabs. See, 3D equation is there for Cartesian, polar, and cylinder. But further, the 2D till here, this is the first module, first chapter. Till here, first module, first chapter. First module, second chapter is this 2D equation for slabs. Under that slab, there are so many conditions. What is that? Slabs arranged in parallel, slabs arranged in series, contact resistance, then combination of H and K. So these are all the 4 conditions we are going to solve the problem. Okay, there is derivation for all these things. What is the procedure for derivation? I told the standard, there is a standard procedure. See, if there is multiple slabs like this, we will take A, B, C, LA, LB, LC, KA, KB, KC. The rate of heat transfer Q, left to right, we are going to take, and left side is higher temperature and right side is lower temperature. If there is a fluid here, I can write down this is the arrangement for heat transfer. If there is fluid on either side, I can rewrite the same figure in the form of electrical analogy. What is that? Second resistance, third, fourth, fifth, and Q. That means this is resistance due to convection. Resistance due to A, RA, RB, RC. Then again convection outside. Okay, resistance due to convection inside, convection outside, RA, RB, RC. So I am rewriting this equation, this figure in the form of electrical analogy. This is also important. He has asked in many questions. He has asked you to write on the electrical analogy. Then, if this is arrangement, he also may ask, what is the temperature of the body inside? What is the temperature of the body in between A and B? What is the temperature of this between B and C? And he is asking you to draw the profile. So how to draw the temperature profile? Profile will be left side will be higher. It will reduce. It will reduce still it will reduce, and reduce. So this is the temperature profile. This is called Ti, T0. In between T1, T2, T3, T4. Any doubts still here? Any doubts still here? See, first module, in the first chapter, there is no much complicated problem. Problems are very simple. And in the second chapter, concept is very simple here. So take the Q here from left to right. So what is the basic equation for the Q where I used to explain? Q is equal to delta T by sigma R. So wherever the delta T we are taking, if you are taking only convection, then you write only one R, that is Ri. If you are taking both convection and conduction, that's material A, then delta T will be Ti minus T2 divided by Ri plus Ra. So like that, that is a formula. You can write this for the same arrangement. I can write the value of Q. That will be same. How many equations I can write? 1. Combination of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 equations I can write only for this figure, for the Q. But all the 15 equations I used to write by using the same formula, delta T by R. Whatever the delta T we have taken, divided by R should be between that. See, if I taking delta T from Ti to T naught, if delta T is Ti minus T naught, then include all the resistance. What are all the resistance? Ri, Ra, Rb, Rc, R naught. If I take delta T from Ti to T3, then how many resistance will come? Only 3. That is Ri, Ra, Rb. Like that, wherever you are taking the temperature difference divided by that resistance, you have to include, so that we'll get the value of Q in terms of delta T by sigma R. Okay. So entire chapter holds on this formula only, delta T by sigma R. But you should know what is sigma R. I'll explain that. The sigma R is nothing but combination of different R's. R for convection. What is the formula? R for convection? 1 by Hi into E if it is inside, and 1 by H naught into A if it is outside. That means inside fluid we are going to use this formula. For outside fluid we will use this formula. And R for conduction is equal to L by Ka. So if you are taking material A, everything you take it with respect to E. If you are taking material B, take with respect to B. If you are taking material C, take with respect to C. So what is the unit of this and unit of the resistance? Degree centigrade per watt. Degree centigrade per watt. So that is the value of the resistance due to the materials or due to the convection. Okay. Then what? So these are all the important points to be discussed. And there is no problems in the syllabus only has given. No problems on cylinders and concentric spheres. Concentric cylinders with the concentric spheres, there is no problem. So no need to worry. You worry about only the slabs. Worry only about the slabs. Either it's Kelvin per watt or degree centigrade per watt is the equation for the unit for R. Then what else you can ask after this? You can ask about one more thing I forgot. Different boundary conditions. There are 3 kinds of boundary conditions. This is first kind, second kind, third kind. There are 3 kinds of boundary condition. First kind, second and third boundary condition. That also explained. Okay. Definite question of this boundary condition in exam. He will ask you to write down the boundary conditions. You have to write down the boundary conditions. Okay. Then this I'm having a look. Just have a look of the syllabus. Next, what is the next thing is? Okay, these are all the things we have explained in the first module. And one more, if the slabs are arranged in parallel, so what is the figure I have shown is parallel. If the slab is arranged in series, if the slabs are arranged in parallel like this, so this is A, B, C, and D. Length of A, length of B is equal to length of C, length of D. So in this case, electrical analogy is like this. So first what we need to do, this is Ra, Rb, this is Rc, Rd. We have to convert this parallel arrangement into series. So that means Ra we have to do, RBC we have to get, RD we are supposed to get. So what is the equation for RBC? Converting the parallel into series. What is the equation? Use that equation and find out RBC. Substitute that value as RBC as. Again, we are just converting this parallel arrangement into series and we are going to try to solve the problem and find the value of Q. So this is about arrangement in parallel. And there is something we did, that is contact resistance. What do you mean by the contact resistance? What do you mean by the contact resistance? That means If there are two slabs or three multiple slabs, due to the roughness of the slab, there may be a chances of air entrapment between the material. So if there is air entrap, that means there is a resistance occurring at the middle. Till now, what we solved? We will be having only T1, T2, T3. This is the only temperatures we will be having whenever two slabs are connected with each other. Now, what is the concept is if there is a rough surface, and due to the rough surface, if there is any entrapment of the air, then what will happen? The drop in temperature takes place between the material A and within the contact. That is, this will be T3 for us, T2, T3, and here we'll be having T4. And how the profile will be? Profile will be like this. T1 will be here, T2, this is T2, this will be T3, this will be T4. This is arrangement for temperature profile if there is any contact resistance occurrence. So for that contact resistance, there is no formula for R. That R, contact resistance R, will be given directly in the question. So take the R. What is R for this material A? L by Ka. R for material B is L by Kb. But what is this resistance for the air entrapment? That resistance, there is no formula. He will give directly the resistance for the air entrapment between material A and B is so and so. So use that R, find out the value of temperatures or whatever he is asking. Either he may ask you to find the length of the material B, Q, something. After this, we also did something about heat generation. There are two plates, plate A, other side plate B, and there will be heat generation inside. Due to the heat generation, the heat transfer takes place on both the sides. But the value of Q on both the sides will not be same. Heat generated here is, for example, 1000 watts. The Q here may be different. Q may be here, it will be different. But if I add up these two, I supposed to get Q is equal to 1000 watts. So if the material is same, if the thickness of the material is same, and H outside will be same, temperature, everything is same, then these two values will be same. If the material thickness is different and the material B is made up of other material than A, then the value of Q left side and Q right side will be different. You have to find out both of Q, add up those two, so that you have to finally get the value of Q total as same, which is input. So this kind of problems also we will solve. Correct? So this is about the first module. Is there any doubt in the first module? Now I briefed about what are all the concepts we are going to have in the first module. Whatever the thing is there as per the syllabus and how we did, how we solved the problem, everything I have explained. Now you ask me any doubts in any of the problem, I'll try to address that so that it will be clear, the doubts will be clear. I shared the notes of that notes, whatever I have done in the class, that is first module and transient in the Google Classroom. Everybody has collected that notes I have shared from taking the photo of your friends, means whatever he has written. I think Pavan, I think Pavan has written the notes. That same notes I have shared in the Google Classroom. Okay, please go through that notes and then prepare well for interviews. I have shared in the Google Classroom whatever the topic I have covered in the theory class, in the regular class. That notes I have not shared my handwritten notes. I have shared the notes which I have done in the class. That is, Pavan has taken the notes. The same notes I have updated in the Google Classroom. All of you please download and have a look if you have missed any classes. Then any other doubts in the first module? So if anybody having doubts, please ask me. Okay, I hope there is no doubt with the first module. Nobody is asking. Good. Then we'll go for the second module, that is transient heat conduction. There, three parts. The chapter is divided into three parts. So first one is lumped system analysis. Second is infinite solids. Third one, semi-infinite solids. In the lumped system analysis, we are going to have problem. We are going to find if HLC by K is less than 0.1. If HLC by K is in between 0.1, it is greater than 0.1 and less than 100, we'll go for infinite solid. If HLC by K is greater than 100, then we'll go for semi-infinite solids. We have solved all the types of problems. Here, we are having a formula. This formula is available in that handbook. That is Ti minus T infinity minus T naught minus T infinity is equal to e to the power of minus Biot number into Fourier number. Here by using charts. Here by using again. Hey.
Sir, we don't have data handbook, sir. Can we open during the internal, sir?
Yeah, you can open data handbook. I was given in the Google Classroom. No, you are shared in the Google Classroom.
Sir, during test we can we open data handbook in our system, sir?
Yeah, you can open. Hello.
Okay. Okay.
You can open, no issue. But nobody will ask you. No, just we'll give the question. You have to answer that. Find out the solution. You have to answer. Then, anybody having doubts? See, this is a brief about the thing what I have covered to the transient and with respect to the first module. If anybody is having doubt, ask me. If any particular problem, if you are having a doubt, if you share so that I will solve that problem and clear your doubts. Okay. So how to identify between these two, whether it is a lumped system analysis or infinite solids? Just you identify if there is some material. If I keep that material in here, after some duration, if you have body, what is that? To find out the temperature of the body at somewhere else, that means at the surface, then definitely it comes under this charge method. There are two methods to identify whether the given problem is charge method or lumped system. By using this formula or by reading the question itself, you'll understand. He will be giving the temperature of the body is something first. After some duration, the temperature of the body is how much? Then definitely it is lumped system. Same thing. If the same sentence, if the temperature of the body is something earlier and it is kept in here, after some duration, the temperature of the body at the mid plane and at the surface is how much? So he is asking that two times. One is at the center and one is at the surface. That means depending upon the location he is asking. In that case, that problem to be solved by and Gruber charge. Okay. Similar procedure you have to adopt for slab, adopt for cylinder and sphere. There are 9 charts in this. Out of 9, you must select first which is the given condition, whether it is a sphere, cylinder or a slab. Based on that, you should select the charts. Anybody having doubts? So, any doubts came down there, what I should understand, whether shall I proceed? And again, in this chapter, you can ask significance of Biot number, significance of Fourier number. Significance of Biot number and Fourier number. No need to remember the formula for Biot and Fourier number. That is there in data handbook. Whatever I shared in the Google Classroom, it is in page number 111. Check out what is Biot number, write the significance. Check out what is Fourier number, write the significance. Matten beku. I hope that is enough, no? Gautam.
Sir.
Anything else required? If you require, you please tell me so that I'll solve. I'll go with that. Any doubt?
No, sir. That's all, sir.
Okay. This is about the briefing about the thing, whatever we did. Please go through the earlier notes. If you're having any doubts, ask me. I'll clarify that problem. Particularly, I'll take up that problem and I'll try to solve and address the issue. So today means whatever I done till now is just briefing about the things what I covered before the lockdown and what is there for the syllabus of first internals. Again, I'll repeat, the first internal syllabus will be based on MCQ. 1 marks each. 30 questions will be given. Okay, you have to address all the 30 questions. All the 30 questions will be MCQ based. Few of them will be theory based and few of them will be on problematic based. Okay, so problematic based means, for example, one question I'll give. Based on that one question, 5 different questions I'll give. Means sub questions will be there. So each question will be having one like that. So prepare for theory as well as the problems. And be ready whenever the test is there. Be ready with the calculator and data handbook. Without that, it is very impossible to solve. Okay.
Sir, 1 hour, no, sir, duration?
1 hour for heat transfer, 1 hour. For heat transfer subject, 1 hour is the duration. Please log in to the exact time. Once you log in, it will come only 60 minutes. Then automatically this will be disconnected. Okay. So you know how. Huh?
So the window time will also be 1 hour.
Window time is also 1 hour and the test time is also 1 hour. If you start the test 10 minutes later, then you'll be having only left out with 50 minutes. You'll start that. If you start the test by after 20 minutes, then you'll be left out with only 40 minutes. So start the test exactly at the time allotted. Okay,
Okay, sir.
1 hour you'll get full complete fetch. You can get 1 hour. You can solve all the problems. So be ready with the calculator and then data handle to solve the problems. Okay. So that's all about the theory part. That's all about the test. We'll come back for the convection. We'll come back for the convection again. I think probably today it is possible to complete only one problem. I'll solve that and I'll wind up. Okay. You tell me, yesterday we left out somewhere. Where we left? Did you solve? I told you to solve something and come for the next class. What is the value of block you got? What is the value of the breadth of the block? See, why I told you to solve that is because there different Nusselt number, not as the same natural Nusselt, which standard Nusselt number. So I'll brief what is done yesterday. He has given a cylinder of some length and some diameter for case 1. So he has asked you to find out the Q. You know how to solve the Q for this case. So how to solve? T-film, properties of T-film, Reynolds number. Based on Reynolds number, that is turbulent and laminar. Nusselt number formula will take. Based on Nusselt number, you will find out the value of H. Substitute that H in Q. You will get the value of Q. So this is one set. What we did earlier already, we have solved the problem on cylinders. Similarly, what he is telling, instead of cylinder, taking the diameter, if for example diameter is 5 centimeter, let us take the block, square block, which is having 5 into 5. This side is also 5, this side is also 5. That is nothing but equal to diameter. So now, what he is telling something. In the last part, what he told us, we'll find out the volume of this first. Volume of this is pi by 4 into d square is the area into length. We will get the volume of the cylinder. So what he told, volume of the cylinder will be equal to volume of rod. He told volume of the rod, which is square. Volume of the cylinder will be equal to volume of the rod, which is square. So if the rod is square, what will be the volume? That means this is a figure. If this is a rod, so what is the formula we take? Can anybody tell? For volume. So this is L as usual. This is width and this is breadth. He told it is a square rod. Therefore, W is equal to breadth and length. So here also area into length is the formula. So what is the area for this volume? Area will be B into L. Can you tell what is the volume for this? Volume for this arrangement? W into B into L. This is the volume for this solid rod. So it will be this is nothing but B square into L. This is the volume for the rod. That must be equated to pi by 4 into D square into L. So length is same, D square. So try to get the value of B in this, I told. Try to get the value of breadth, that will be equal to width. So yesterday we did till here. Remember? Yesterday we did till here. So he told to find out the value of Q for the cylinder, all the data are given. So what he told, take the same data for the slab out, for the square block, but you take volume of both are same. So you first find out the width or the breadth. Hence he told it is a square. Both the width of the block and the breadth of the block will be same. So let us find out the breadth or width. This is important for this problem. First you find out. I told you to find out this still here. Have you found out what is width of the block?
So 0.035.
0.035
meters.
0.0. No, I got 0.265. I got 0.265. So what is the diameter of the material given? Diameter of the material is 0.3. Length was 2 meter. So convert this. Pi by 4 into D square into L. That will be equal to W, width square into L. So L and L will D square is 0.3 square. That will be equal to width square. So take out width in this. Width of the material or breadth of the material is how much? Pi by 4 into 0.3 square, root of the answer is 0.265 meters. I got this as the answer for width of the material. Means
Yes.
Instead of cylinder,
The correct answer, sir.
okay. Instead of cylinder, if I keep a square block and the air is passing over the square block, what is the first you find out? He is asking Q, but to find out Q, we want this, the dimension of the block. So dimension of the block we know now. This is the dimension of the block. Then we will go for the problem for the block. So assuming we know this, how to solve? What is the first step to be solved? Again here, the first step is TF. Is there any change in TF for cylinder and the slab and this square rod? There is no change because he told the material, the temperature of the cylinder as well as the square block is same. Hence it is same and the fluid temperature is also same. That means film temperature will be same. What is the film temperature we got for the cylinder? We got for the cylinder 20 degrees centigrade, correct? So second step is properties. Say I'm solving for case 2. What is case 2? Case 2 is a block. Instead of cylinder, it is a block. Properties are also same for the cylinder as well as for the block. There is no issue with the properties. Then third one is Reynolds number. This is important. What is the Reynolds number we took in the cylinder? That is rho Vd by mu. Here rho V breadth by mu. Or it is also called as rho V width by mu. So how to take whether breadth or width? Hence here in this problem it is same. Breadth and width is same, having the same values. If the material is given rectangle, how to take? How to take? If the material is given rectangle, how to take? Observe here. If this is a square block, means cylinder is converted to square block now. Now the air is passing over the surface. If the air is passing over the surface, whatever the surface which is exposed to the air, that is the distance we are supposed to take. Hence, it is a square. This will be equal to this. If it is rectangle, then this dimension will be different and this will be different. Means width will be different and depth, breadth will be different. Always you take which is perpendicular to the air motion, which is perpendicular to the direction of the air. That we are going to consider to write the Reynolds number. For this problem, rho VB by mu is equal to rho VW by mu, because B is this, W is this. If it is rectangle, the formula, I cannot write the same formula as equal. Correct? So we'll solve that problem also. Assuming the rectangular slab, the air is flowing, how to solve? We'll solve that. So for time being, we'll solve the Reynolds number. So what is the Reynolds number we got for this arrangement? What is the Reynolds number? I got velocity. Rho is how much? We got yesterday we did already, but we did a rho v d by mu. Now it is square, so we will take rho v b by mu. Re is equal to 176540.5. Correct? We got this. Correct? Huh? Hello? Hello?
Yes, sir.
Okay. So we got Reynolds number for this square block. Now what is the equation we're supposed to use? We're supposed to use Nusselt number. So which is the equation we'll use for the Nusselt number? If it is a cylinder, we know it is C into R to the power of Reynolds C into Reynolds number to the power of M, Prandtl number to the power of 0.333. That we know. If it is cylinder, you just open the data handbook, write the page number. Data handbook page number. I'll share whatever the data handbook I shared. I'll tell the page number in that data handbook. Okay. Okay, you see here. Flow over cylinders. Page number 115 in the data handbook, what I shared. There we got, if the cylinder is given, Nusselt number will be C into Re to the power of M, Prandtl number to the power of 0.33. That we know how to solve. We solved the problem already. Now, the given solid is not a cylinder. Now the given solid is something else. So that, what is the page number I'll go? I'll go with page number 11. See, in the page number 115, you check out the equation number 2.1.2. He has given clearly there, flow over non-circular shapes. Flow over non-circular shapes. Now the shape, what we done is a non-circular one. It is a square shape. So what is the Nusselt number formula for that? Non-circular shape. Non-circular Nusselt number is 1.1 into C. 1.1 into C. Re to the power of N. Prandtl number to the power of 0.333. So how to get the value of C and N? That is also given there only. How to get the value of C and N? You check out. The value of C and N is available in page number 118. You go for page number 118. You check out different configurations. Now the configuration is square for us. So for the square configuration, Can you tell what is C and what is the value of N from page number 118? From page number 118. Anybody tell? Check out the square configuration. How it is arranged? It is arranged like the last but one or last but second one, correct? Square arranged with last but one. From Ari. So last but third one. So we got C is equal to 0.092 and the value of N is equal to 0.675. Substitute back here, you will get NU. So that NU value is 313.15. So this is.
Sir, there are two squares, no, sir.
Hello?
Sir, there are two squares in data handbook, no, sir. Which one do you need to take?
That better you take the first one. See, that is based on, you check out here, based on Reynolds number. What is the Reynolds number we got? We got the Reynolds number in the form of 1,76,000. So check out, there are two squares, of course. But out of those two squares, which is the one we are preferring? If the value of the Reynolds number is 5,000 to 1 lakh, use the above equation. If it is 2.5 to 8,000, use the second equation. Now we got around 1 lakh, 1,76,000, but that is not there in that. So we'll preferably take 1 lakh, 5,000 to 1 lakh. If the Reynolds number is 5,000 to 1 lakh, you take the above third one from the bottom. Arthat Anil?
Yes, sir. Yes, sir.
Okay, you take that. So once the Reynolds number is done, find out the Nusselt number. What is the Nusselt number formula? Again, HL by K. This is the Nusselt number. So here, can anybody tell what is the value of L I supposed to put? HL by K. HD by K is for sphere or cylinder. What is the value of L I supposed to put here? This is not L. This is H breadth by K. So instead of this equation, I'll substitute this. See, this is configuration. Which configuration? What is the formula I'm supposed to use? Standard formula is HL by K. But for this problem, I'm substituting HB by K. Because this B is nothing but the area which is exposed. Means this surface which is exposed is B. Okay, you're supposed to take HB by K, not HL by K. So once you know HB by K, so if it is cylinder, what you did? HD by K you substituted. Now, why D by K? See, if this is a cylinder, if the air is blowing, we are taking the entire D as the exposing area. So here, this is the shape. If the air is blowing, means you're supposed to take this length. So we have taken B. Substitute and get the value of H. That itself is H average for the cylinders or other type of fluid. Can you find the Q after this? Find the Q after this, fast. I'm not having the answer. You please tell me the answer. First, you tell the value of H. Will you do? Will you do this? I hope you can do this. The value of Q for this I got is 1276.1 watts. And the value of H I got 30.67, 30.67. Here, if I substitute here, I'll get H first. H is 30.67. Substitute that H in Q. So I'll write the Q formula also because Q is also different here. What is the Q formula? HA T wall minus T infinity. So H is, I told now, 30.67 into area. Can you tell what is the area of this material which is exposed to air? Area is
B into W.
B into W if I do. That is, B into W is this surface. This is not exposed to air. The air,
L into W, sir.
this is here. L into W into 2 sides, plus L into B into 2 sides. So this is the total area of the material which is exposed to the air into TW minus T infinity. Clear? L into W into 2, L into B into 2. Hence W and B is same. I can rewrite that equation as W into L whole multiplied by 2. This is the area I can rewrite. 30.67 into TW minus T infinity. This is Q. Why I taken this? Because, so this is 4. I know this W is equal to B, so I take a return like this. If it is rectangle, you're supposed to use this equation. If it is square, directly same thing, I rewritten this in the form of 4 multiplied with 4. Find out the Q. I got the Q as 1276.10 watts. 1276.10 watts. Okay. Okay. I hope you can complete. All of you type your US number, you can leave the class. Attend for the next class.